In this section, we're going to work with solving proportions. These are special kinds of equations. So before we jump into what the steps are, we're going to start by just defining what a proportion is. A proportion is where we have one fraction, a over b, referred to as a ratio, equal to another fraction, c over d. So to the right, we have an example where I have one fraction on the left side equal to one fraction on the right. And what's nice about proportions is that we can always clean them up so that we can solve and completely clear out the fractions altogether. And I always think of so essentially, when I have this proportion, a over b equals c over d, I can take what we call the cross product. I can take the product of a times d and set it equal to the product of b times c. So we have AD equals BC. So when we're solving proportions, we first find the cross product. We take our rings and we eliminate that fraction altogether. And then we go to town like we did with all the other problems. We isolate the variable, we get all of our variables on one side, constants on the other, and then we solve for that variable. And you're going to be plugging in or showing your work, so make sure you show all your steps. Let's try the first problem. So I see 3/4 equals x over 8. So I'm going to take the cross product. So we've got our rings. We've got 4 times x, that's 4x, and 8 times 3 is 24. And look at that, that's so nice and neat. So now I've got 4x equals 24. We divide both sides by 4 because we're trying to get that x by itself. And we get that x is 6. Let's try another one. Let's look at 3. So for 3, we have the cross product that looks like this. This is a little bit different because we've got more than one term in the numerator. So we would then set this up for ourselves. We are taking -2 and multiplying it to the quantity of x plus 8. And we set that equal to, and now we take the product of -3 and set that equal to the quantity of 17 minus x. Next comes our distributive property. So we're going to distribute on both sides of the equation. So that would leave us with, I'm going to move down here, -2 times x is -2x. -2 times 8 is -16. And we set that equal to -3 times 17 is -51. And -3 times -x is +3x. Scroll up. And now, folks, we want to get all of our x terms on one side, constants on the other. So I think I'm going to add 2x over to the other side. So we're going to add 2x. So that leaves us with -16 on the left side and -51 plus 5x on the right side. So the next step is we now want to get that 51 over to, so the next step is we now want to get that -51 over to the other side. So we do the inverse. We add 51 to both sides. So that leaves us with 35 on the left side and 5x on the right. We divide both sides by 5 and we get 7 equals x. And I'm going to use my symmetric property to then say if 7 equals x, I can write that as x equals 7. And let's end on 4. So if I'm to solve and I've got a proportion, I'm going to take the cross product of that, which leaves us with 8 times the quantity of 4 plus x, and I can set that equal to 48 times the quantity of 3 minus x. And just like before, we're going to distribute, because we see we've got that 8 and 48 multiplied to multiple terms inside the parentheses. So here we have 32 plus 8x equals 144 minus 48x. Numbers are big, concept is the same. So now let's add 48x to both sides of the equation. And I think that's 56x on one side. Oh, still got that 32. And then I've got 144 on the other side. And so we want to get x by itself. So next we subtract the 32 to move that over to the other side, leaving us with 56x equals 112. And lastly, we divide, since 56 is being multiplied to x, we divide both sides by 56, and we have that x equals 2.